Hi, it's Kiffin Bates here, and today I thought I would do a little video on fixed point arithmetic. And I can already sense some people thinking, well, what is fixed point arithmetic? Why should I care? And what on earth does it have to do with blockchain? And I'll go through those in turn. But first, just a little chat about computer architecture. You see, computers are very good at dealing with whole numbers. But if we want to deal with, for example, negative numbers or fractional numbers, then we have to build structures on top of them in programming languages in order to be able to cope with that. And developers will be familiar with float types. These are variables that represent numbers that include decimals. And float there stands for floating point arithmetic. However, I found that a lot of developers are not aware of fixed point arithmetic, and yet it's strange because all of us are actually surprisingly familiar with it. If you use a currency, you've already internalized the concept of fixed point arithmetic, and in most currencies we use fixed point arithmetic down to 2 decimal places. So for example, if you're dealing in US dollars, the dollar can be split down into cents. Up to 100, there's 100 cents in a dollar, and that is represented by 2 digits after the decimal point. So prices in the US, if they are given in dollars and cents, only go to 2 decimal places. You don't see shops advertising products to 3, 4 or 5 decimal places, even though technically they could. You know, you can have a product that is has a cost of 0.1 cent, so that would be $0.001, and if you were to buy 10 of them, then it would cost you 1 cent, and you could actually pay for it with a little shiny copper coin. And in fact, there are countries out there where they use fixed point arithmetic to 3 decimal places. For example, I think Egypt uses the Egyptian pound, but they don't have pennies, and they don't have 100 pennies in a pound. They have 1,000 in their pound, so they give the prices to 3 decimal places. So this is where we then can get on to what the relevance is to blockchain, which is if, for example, you take Bitcoin. We talk about Bitcoins as though they're an entity, but the base unit for Bitcoins is actually the Satoshi, and there are 100 million of them in one Bitcoin. And this is just a human construct. It's just a way for us to think about it, because there's nothing in the actual protocol code that talks about Bitcoins. It talks in Satoshis. And this means that you can do things like division a lot easier. If you had 1 Bitcoin and you were representing it as an integer and you wanted to divide it by 2, you would end up with a half, and you can't represent a half in a computer. But if you say to yourself, well, 1 Bitcoin is actually 100 million Satoshis, I'm going to divide it by 2, now we have 50 million Satoshis, and you can store the number 50 million in a computer very easily because it's a whole number. In fact, you can see that you can do divisions right down to many, many decimal places because you've used a base unit that has many digits after the decimal point. So Bitcoin actually does fixed point arithmetic down to, what are we looking at? 1, 2, 3, 4, 5, 6, 7, 8 decimal places. And then if you look at Ethereum, 1 ether is actually 10 to the 18 Wei. Wei is the smallest unit in Ethereum, and again, it means that they're actually doing fixed point arithmetic down to 18 decimal places. So as long as you're dealing with, say, 1/10 or 100th or 1,000th of an ether, and you're doing divisions, what you're actually doing is you're dividing numbers with either 17, 16 or 15 zeros behind them. And again, if you're chucking away the remainder, it doesn't really matter because it's still going to be very accurate. So this is the relevance of fixed point arithmetic to blockchain. And when you look at, for example, creating a token on Ethereum, what you can do is you create your base token unit. And then what you can do is you can say how many decimal places you want to represent it by. So you can do the same thing as is done with ethers and Gwei. You can create your own token. Let's say we call it a Kia token. And what we'll say is that the base unit is actually going to be down to a million. So we'll have 1 million of the base unit equals 1 Kia token. And in Ethereum, in the contract, you're going to represent it using these base units, and then when something like MetaMask displays it, there's actually a little field in the contract that says how many decimal places you're supposed to show, and I can put in there that I'm going to have it down to 6 decimal places for my token. And underneath the hood, we're dealing with those base units again. So there you go, that's fixed point arithmetic. As I said, it's very simple. If you've spent dollars and pennies, or you've spent euros and cents, then you've been using fixed point arithmetic down to 2 decimal places. Everything is represented with just 2 decimal places. In Bitcoin, you do it down to 8 decimal places, and in Ethereum you do it down to 18 decimal places. But it's fixed because past those decimal places you just chuck the rest away, and you rely on the fact that the numbers that you're actually dealing with are so big that throwing away the remainder is an insignificant amount. It becomes a small rounding error that's insignificant. So I hope that explained it, and I hope there are some developers out there who suddenly a light bulb's gone off and they find dealing with ERC20 contracts, for example, a bit easier. And I'll see you in the next video soon. Bye for now.